Good morning, students. Today let us all see the hierarchy of language. In the first unit we saw this Venn diagram. So the interior subset is your regular language, then context-free language, recursively enumerable language, non-recursively enumerable language. Okay, now today's topic is PDA, Push Down Automata. Right? Let us see the informal definition. Informally, a push down automata is an NFA epsilon with a stack. We are using stack as a data structure. You all know that stack is last in, first out. The two major operations are push and pop. Right? Now, transitions are modified to accommodate stack operation. A DFA can remember only a finite amount of information, whereas a PDA can remember an infinite amount, certain types of information in memory stack. In DFA, each state remembers a finite amount of information. To get 0 power n and 1 power n, where 0 is less than or equal to n, right, that is n is greater than or equal to 0, with a DFA would require an infinite number of states. Whereas if you use PDA, we can solve within 2 states because it is using stack as a data structure. The formal definition of PDA is it has 7 tuples. The first one is a finite set of state. Second one is the input alphabet. Third one is a finite stack alphabet. Then Q0 as usual is a starting state or the initial state. Now Z0 is a stack symbol. Right? So we are supposed to push inside the stack Z0. Then only we will proceed with the task. F is a set of final or accepting state which is a subset of Q. Delta is a transition function. Right? So delta into sigma union epsilon along with the given finite set of stack alphabet. Okay, so it will result in finite subsets of Q cross stack clean closure. Right? Now let us see the PDA transitions. Now it is triples. Q comma A comma Z. Q is the state, A is the stack symbol, and Z is A is the input and Z is the top of the stack. And the resultant is your set of resultant state and what is the operation you do, whether you do push or pop. Right? So current state is Q, current input symbol is A, symbol currently on top of the stack Z, move to state Pi from Q, replace Z with gamma I on the stack, leftmost symbol on the top. Move the input head to the next input symbol. So you have Q, right? So A bar, Z bar, gamma 1, P1. So likewise it goes. So these are the resultant states for the given input transition. Let us see for 0 power n, 1 power n, where n is greater than or equal to 0. Right? So we need two states Q1 and Q2, and the two input alphabet are 0, 1, and we are using the stack alphabet as L, hash. Delta is the transition, Q1 is the starting state, right? And then we have hash, then null. Right? So it means that in our pushdown automata we have acceptance by empty stack method or final state method. In the case of empty stack method, we will be popping Z0 finally. In the case of final state method, we will keep the final state as accepting state and we will not pop Z0. Right? So informally here, a string is accepted if there exists a computation that uses up all the input and leaves the stack empty. If you see this delta Q1, comma 0, comma hash, the resultant state is Q1, comma, you are pushing the element into the stack. Right? So already the stack is having hash. Hash is the bottom of the stack. Now instead of 0, I push L. Now when you find 1 and you are in the state Q1, you don't do anything, null. So when you find L, when the input is 0, right? So it means that you are pushing it. That is all zeros I push. The logic is like this. Push all zeros into the stack in the form of L. For every one, you are supposed to pop the content from the stack. Finally, when you reach the end of the input string, that is epsilon, your stack will have only hash, the bottom of the stack. And since it is empty stack method, right, what we are doing is we are finally popping it. Okay, thank you students.